The first law tells us about the total change in energy for a system. However, we are often in chemistry doing things under constant pressure. So we can apply this first law to a system which is at constant pressure. So remember that the energy transferred as heat is equal to the heat capacity times a change in temperature. And that work can be calculated from an integral of the pressure over a volume change. If the pressure is constant, then we can pull the pressure out of the integral and we can write that the work is equal to minus P, the integral of dV, but the integral of dV is just delta V, and so finally we can write that work is minus P delta V when we're at constant pressure. So if we apply that to our first law equation, then we get the following for the total energy change at constant pressure. If we're interested in the amount of heat transferred, then we can write that delta E plus P delta V, so just subtracting minus delta V or adding P delta V to both sides will equal the amount of energy transferred as heat, or the specific heat times the change in temperature. This particular, so I'm going to remind myself that I'm at constant pressure by tagging that Q with a sub P. This quantity is what we call the enthalpy. And we give it the symbol delta H. Fundamentally, delta H is the amount of energy transferred as heat under constant pressure conditions. And since in chemistry we do things under constant pressure most of the time, this will be our measure of the change in energy at constant pressure.